Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back again to this TV Learning Series program. As usual, I'm Teacher Patrick. This time around, I'll be taking you through Chemistry Senior 3. I don't know whether you still remember what we talked about in the previous. We have had a number of sessions together, but if you remember, we talked about chlorine and its compound sometime back we talked about that, chlorine and its compound. I don't know whether you still remember what we talked about in chlorine and its compounds. Right, I remember we talked about, the last part that we were talking about was about the chemical properties. So even today, it is a continuation of the chlorine and its compound. So we are also going to look at the chlorine and its inorganic compounds. So we have to be specific with the inorganic compounds because there are other organic compounds of chlorine. So you have to meet other organic compounds, probably when you go to Senior 5. But this time, we are just emphasizing the inorganic compounds. That is where chlorine exists. So that is why we have to emphasize the inorganic compounds. If you remember, the last part was about the breaching action of chlorine. The breaching action of chlorine. And I just want to take this opportunity again to remind you about the breaching action of sulfur dioxide so that we can compare these two. So that was the last reaction that we talked about. The breaching action of chlorine. So this is just to remind you of what we mentioned last time. Still, if you still remember even what we talked in one of our practical lessons, we prepared chlorine and we were able to see how that chlorine breaches. So we said chlorine breaches in presence of water. So dry chlorine, you need to take note of that. Dry chlorine does not breach. So this forms two acids, the hydrochloric acid and this. So I don't know whether you still remember what is the name that we gave this compound. I don't know whether you still remember that. So good. So we said this is chlorine water. So the breaching action of the chlorine is as a result of the chlorine water. So this chlorine water, which is also called hypochlorous acid. This is hypochlorous acid and hydrochloric acid. So when this hypochlorous acid reacts with the dye is a colored material. Any material that is colored is called a dye. So when it reacts with the dye, then it gives away its oxygen. You remember I had even mentioned, I think it was in practical lesson, where I mentioned that these breaching agents are either oxidizing or they are reducing. So in this reaction, so the dye accepts the oxygen. So the dye accepts the oxygen because this compound is very unstable, so it easily decomposes to give that oxygen to the dye. So this one here, this is colorless. And then you have the hydrogen chloride gas, or the hydrochloric acid. So this becomes colorless. Either the dye accepts the oxygen, and if you remember very well when we were talking about the oxidizing and reducing agent, we said that oxidizing, in terms of oxygen, is the addition of oxygen. So oxygen has been added to this. So that is why we say that chlorine oxidizes by oxidation method. Oxidation method. Because it accepts the chlorine, it accepts the oxygen. If you still remember very well, the sulfur dioxide, that is why I said I take this chance to also talk about the breaching action of the sulfur dioxide, because it is also a breaching agent. Just a reminder. So if we have the sulfur dioxide also does not breach in the absence of water. So it also breaches in the presence of water. And this forms a very weak acid, which is sulfurous acid. And this one decomposes, because it is a very weak acid, so it partially ionizes in the solution to form the hydrogen ions and the sulfate ions. So these sulfate ions are the ones responsible for the breaching action. So we have the sulfate ions, which will combine with the dye. The dye is DYE, not DEY. So it is the dye, and see what happens. Plus, so if you have the dye, this dye now, look at this. It means that the dye, this is colored as usual, and this is colorless. What's the meaning of this? The dye is the one now giving away the oxygen. So it gave this one oxygen, it gave this one oxygen. So that is what we are talking about. So this is when you look at this one, and this, you see that that one, the sulfur dioxide, its breaching action is as a result of reduction. So this is the reduction method. So sulfur dioxide breaches by reduction method. So this was the last reaction about the breaching action that we mentioned. If there is any other, maybe you can also remind me. So let's straight away go to the compounds of chlorine, these inorganic compounds. So what we are starting with will be the hydrochloric acid. So the hydrochloric acid is one of the compounds of chlorine. I don't know whether you still remember some of the compounds of chlorine that we mentioned. Yes, we also mentioned sodium, the chlorides of metals and other chlorides. So we have hydrochloric acid. Also, we also have hydrogen chloride. If you remember very well, I had mentioned this one, I think even in the previous session. I said the difference here, the hydrochloric acid, the difference is the state. And therefore, you should take note of that. Hydrochloric acid is aqueous. Hydrochloric acid is a hydrogen chloride is a gas. So we are just going to see first how this hydrogen chloride is prepared. Look at how it is prepared. We also look at some of the physical properties, and then we'll also look at some of its chemical properties. So in the preparation of the hydrogen chloride, gas. So I'll just mention some of the common method that we use in the lab. So we use the sodium chloride. which is in solid form, which reacts with concentrated sulfuric acid. So the concentrated sulfuric acid forms hydrogen chloride gas plus sodium hydrogen sulfide. So I just want to mention that this gas here that is prepared, the method of the correction depends on some of the physical properties. So in using, I'll just try to sketch the diagram. Maybe it may not be the best diagram, but you need to draw the best diagram in your books. So make sure, why am I drawing this? There are some things I want to emphasize here. A common mistake is leaving this flask empty, rather open. So you have got concentrated sulfuric acid, and then you have here sodium chloride. So the biggest problem that we usually see among the students is drawing this diagram and then leaving this flask open. So this one must be closed and leaving this one that brings the acid and leaving this delivery tube that takes the gas. So that is the most important problem that we usually experience. Even when it comes to this one, here we have concentrated sulfuric acid. Again, concentrated sulfuric acid again, and then it is corrected by this method. So what is the name of this method? You can suggest the name of the method. Very good. So this is downward delivery or upward displacement. So this is hydrogen chloride gas. So why is it corrected? So what I was talking about here, don't forget to close. Don't forget to close here, because you may not correct the gas over here, because the gas may escape. If it is coming like this and it finds this one open, how do you correct the gas here? So if you leave this open, to me I'll give you, I don't know how, it depends on what I was giving. Out of 10, I would give you maybe like 4. So that means you'd have to lose the marks. So that is the correction. And the correction, as I've mentioned, depends on the physical property. So the physical property of the gas determines the method of the correction. Can you mention some of the corrections, some of the methods that we use? Specifically this one? Very good. So we use, this one is corrected by, I mentioned downward delivery, because the gas is denser than air. So that brings us to the physical properties. The gas is denser than air, or the gas is denser than air. So that is why it is corrected by that method. It is very soluble in water. Soluble in water. So it will form, when it dissolves in water, forms a strong acid, which will be hydrochloric acid. Soluble in water and forming a strong acid. So all acids have got similar characteristics, similar physical properties. The acidity means that they turn blue litmus red. So if the gas is acidic, then it will turn the blue litmus red. So these are some of the physical properties. But there could be even, there are other physical properties, but these are the most important physical properties that we can mention. Then, probably, as I mentioned before, we look at the hydrogen chloride. Hydrogen chloride is a gas. So, the hydrochloric acid is an aqueous. So, how do we get this hydrochloric acid? Just passing the gas, the prepared gas here, into a solution of water. When you pass it through a solution of water, probably, I will just, this is a simple example. So we are passing this gas into water. This is the water. This is a funnel. Or water, and this is a filter funnel touching the surface of the water. So you have hydrogen chloride gas. It is coming. So this funnel prevents what we call the sucking back. So that's why we use the funnel. So we don't want the gas, the sucking back is the moving back of the gas. So the gas moves backwards into the reaction flask. So we use the funnel, and it should touch the surface of the water. So now if this gas passes through this water, so this one will turn into the hydrochloric acid. Eventually the water that is here will change into the hydrochloric acid. So that is a very simple preparation. So we just usually write this equation, hydrochloric acid, the hydrogen chloride gas, with water. This will give the hydrochloric acid. Or we can write it in this form. Plus the water. The hydrochloric acid gives the proton to this. Acids are proton donors. So they supply the protons. So this one will supply the proton to this. Then it forms the chloride ions plus the hydroxonium ions. These are hydroxonium ions. Just mention the name here. Hydroxonium ions, or sometimes they call it oxonium ions, which is H3O plus. So that indicates the acid. So that is the simple preparation, passing the gas into the water, then you obtain the acid. So we'll have to look at some of the chemical properties of this, of the hydrochloric acid as well. So the properties of the acid are similar. So the acid is not new because it is not a new acid. We looked at the acids and the bases even in senior 2. So some of these properties, we are just reminding ourselves. So the chemical properties of the acid, chemical properties of hydrochloric acid. So we first talk about the reaction with metals. Reaction with metals. How do the acids react with metals? Still remember how the acids react with metals? Could they liberate hydrogen gas? So when acids, that is, remember I've said this is the characteristic of all the acids, not only one acid. So when the acids react with metals, for example, maybe zinc That is one of the examples of the metals reacting with hydrochloric acid. So this one will give zinc 2 chloride, and the hydrogen gas. So this is one of the methods that can be used to prepare the hydrogen gas by the reaction. So the same reaction as I mentioned, metals react with ore acid in a similar way. This is not part of what we are looking at, but I'm just giving an example to refresh your mind. Sulfuric acid also reacts in a similar way. That is zinc sulfate plus the hydrogen gas. So that is an example, one of the methods. So this is the reaction with metals. 2, we have the reaction with the bases. So the basic, we have the bases, we have either hydrogen, we have we may have hydroxides, or we may have the oxides, which are basic. So for example, if we have the bases, this can be oxides or the hydroxides. For example, if we start with the hydroxide, probably say hydrochloric acid plus calcium oxide, this will give calcium chloride plus water. Calcium chloride plus water. So when they react with oxides, they form the salts and water. Salts and water. When they react with the, maybe you can have another hydroxide, or rather another oxide, maybe sodium oxide. This will give sodium chloride plus water. So you need to take note of that, that when they react with oxides, they always produce the salts and water. So if we have the hydroxides, because we said these bases can be either oxides or can be the hydroxides. So some of the hydroxides, can you give the examples of the hydroxides? Good. So the hydroxides are many, so we may use sodium hydroxide as an example. Chlorine plus sodium hydroxide. So this will give sodium chloride and water. This reaction has a special name. Do you still remember the name of this reaction? There is a special name that this reaction has. Very good. So this is a neutralization reaction. Neutralization reaction. Neutralization reaction. So that is with the base. So you can have as other bases as soluble as possible, not necessarily sodium hydroxide. So you can have calcium hydroxide. This will give calcium chloride plus water as well. So that is the reaction with the bases. Then we have reaction with carbonates and hydrogen carbonates. This is number 3. Reaction with carbonates and hydrogen carbonates. So you can mention any hydrogen carbonate, not necessarily one carbonate, not necessarily calcium carbonate that is common, but you can as well have any other carbonate, or carbonates. So when we say or carbonates, we mean or carbonates. So the reaction here, we have either, let's use sodium carbonate, which will react with HCl, and this will give sodium chloride plus water plus carbon dioxide gas. So when it reacts with the carbonate, always remember that it will give the salt, water, and carbon dioxide. Acids and carbonates produce water, salt, and carbon dioxide. The same reaction, the same products are given when we react the acid with the sodium carbonate. Remember, this applies to all acids, not necessarily hydrochloric acid. So you may have sodium hydrogen carbonate. Sodium hydrogen carbonate with the water, with the HCl. This can be in solid form. With the HCl, the products are the same. So we have sodium chloride plus water plus carbon dioxide gas. So these represent the reactions, some of the reactions with the of the acids, said with metals, with the oxides. These are oxides and hydroxides, which are basically all bases. And then we have the reaction with carbonates and hydrogen carbonates. So these are some of the reactions that we are supposed to always remember. And probably there could be even some other oxides. So before we come to the end of our lesson today, I would like to give you an exercise. Please take note. I hope you had your books with you. Take note of this exercise. The exercise also works as the homework at the same time. Hydrogen chloride gas in the laboratory. That is a base state, the physical properties of hydrogen chloride gas. And say, write equations to show how hydrogen chloride reacts with A, water, B, sodium carbonate, and C, sodium metal. With that, we come to the end of our lesson today. I thank you so much for following. I hope we've been together, and I wish to be with you even next time. Bye.